So today we are discussing about derivative of composite functions. NCERT problems, that is derivatives of composite functions. Composite functions. So in this exercise, if we count properly, exactly we have 10 questions as an exercise problems and 3 questions as a example problems. Now to find the derivative of these functions, we need to understand what exactly the meaning of composite functions. In relations and functions, you may have already studied about composite functions. That is, if f is a function from set A to set B, and g is a function from set B to set C, then GOF is a function from set A to set C is called as composite functions. Correct? And this GOF function can be denoted as GOF of x is equal to g of f of x. You can observe here a function g is having one more function in its body, that is f of x. So this type of functions we can call it as a composite functions. In a simple words, if a function is having one or more function in its body, such type of functions are called as composite functions. For example, sine of tan inverse of x. You can observe here the trigonometry function is having inverse trigonometry function in its body. Then we can say log of cos of x square. Even this is also an example for composite function. How it is? Let us see. See, this is a logarithm function which is having cos in its body, and that cos function is having polynomial function in its body. So there are two functions are there inside the function log. So again we call these type of functions as a composite functions. I hope it is very clear that if the function is having one or more function in its body, such type of functions we can call it as composite functions. You can consider some more example like sin x to the power cos x. You can observe this is in the form of trigonometry function to the power trigonometry. Clear? A trigonometry function sin x whole power cos x, one inside the other. Or else even you can consider, even if you don't consider, as of now this type of functions is to be considered as a logarithmic functions actually, but right now we don't want this. Let us consider the composite functions type. That is, we can write some more functions like cos of, sine inverse of, log of x to the power 5x. So here the function cos is having sine in its body, sine is having log is having variable x, and x power 5x again. So these type of functions are called as composite functions. Now directly we will move to the problems like how to find the derivative of composite functions. So there is one example problem. Find the derivative of a function given by, find the derivative of, this is one of the example problem we can say, find the derivative of composite function given by f of x is equal to sine of x square. F of x is equal to sine of x square we have. Now to find the derivative of this function, you can observe here a trigonometry function sine is having polynomial function in its body. So you can consider first function as a sine theta, second function is x square. We all know the derivative of a given function f of x with respect to x is denoted by f dash of x. We are differentiating on both the side. Okay. So differentiation of f of x is f dash of x, that is equal to first function we assume it as the function will look like sine theta. So differentiation of sine theta is cos theta, but in place of theta whatever you have that you should write as it is. We have x square, accordingly I wrote. So here first function is done. We are left with second function into second function is x square. What is the differentiation of x square? 2x. See here we identify the number of functions in the given function. Then we differentiate each function. The differentiated value we write it as a product. That is what the composite function says, or the chain rule. Okay, and then finally we will rearrange the final answer. So differentiation of f of x is nothing but f dash of x. As we have written or we have considered the functions in a forward direction and we are rearranging the functions in a backward direction. So the first function is 2x and the remaining is cos of x square. Finish. This is our final answer. Clear? Now let us understand how to solve the same problem in a simple way. Okay, how to solve the given problem in a simple way. I will assume the given question as y is equal to sine of x square. F of x I am assuming as a y. There is nothing wrong. You can easily assume it. So now here I explained about considering the functions in a forward direction and rearranging from a backward direction. So we obtain the answer. So here we are doing the two steps. The derivative of composite functions can be found in a single step only if you identify the functions from a backward direction. Which means first you identify the innermost function, then the outer function. So if I differentiate accordingly, no need to rearrange, you will get the answer accordingly. That is, differentiation of y with respect to x is dy by dx, which is equal to, the first function is x square we are considering, differentiation of x square is 2x into second function is cos x, second function is sin x, differentiation of sin x is cos of x square. See here you can observe in a single step we are getting the answer. So I prefer this method to find the derivative of composite functions. Dy by dx is equal to 2x into cos of x square. Now let us move to the second question. We have second question as find the derivative of tan of 2x plus 3. Tan of 2x plus 3. Assume we have a second question, that is find the derivative of, tan of, we will assume the given function as y is equal to tan of 2x plus 3. Okay, now to find the derivative of this function, here also you can consider the first function as an innermost function, then the second function as a tan. Trigonometry function is having the one polynomial function in its body. So here 2x plus 3 is to be considered as the first function, second function is tan x. When I differentiate the given function with respect to x on both the sides, we get the answer which is of the following form. Differentiation of y with respect to x is dy by dx, which is equal to, now here the first function is 2x plus 3. Differentiation of 2x plus 3 is only 2 because 2 is a constant, we write as it is, and differentiation of x is 1. 2 into 1 is 2 plus 3. Differentiation of independent constant is always 0. Accordingly, we found the derivative of first function into second function. What is second function here? Tan x. We are assuming this 2x plus 3 as an angle. Differentiation of tan theta is secant square theta. But what do we have in place of theta? In place of theta, we have 2x plus 3. So that one we are writing as it is. So this is our final answer. I hope this one is very simple and you are understanding true. Now let us consider this next question. Sine of cos x square is the next question. Sine of cos x square. Find the derivative of the function y is equal to sine of cos of x square. Okay, now again you can observe here the function is having trigonometry function. Sine is having cos x and x square in its body. Then how to find the derivative of this function? Here also we follow the same procedure. Differentiate the given function with respect to x on both the sides. So here we consider the first function is x square, second function is cos, and the third function is sine. Now differentiate one by one. Differentiation of y with respect to x is dy by dx. First function, differentiation of x square is 2x, which we have completed. Second function is cos x. Differentiation of cos x is minus of sin x. So minus sign I wrote just before to 2x minus sine of x square. In place of theta we have that only, accordingly I wrote. And then the next one is last function is sin x. What is differentiation of sin x? Cos x. Cos x square. Okay, cos x square. Clear? Cos x square. Cos x square. So final answer I am writing again. So dy by dx is equal to minus 2x into sine of x square into cos of x square. Yeah, this is our final answer. I hope you have understood. Now let us move to the next question. Okay, the next question is that is from the exercise problem 5.1. Exercise problem 5.1. 5.1 first question. What is first question in the 5.1? Sine of x square plus 5 is the given question. Sine of x square plus 5. Let us consider the given question as a y. Y is equal to sine of x square plus 5. Okay. Now if I find the derivative of this function, here also you follow the same procedure, dear students. Inner function, within the bracket we have x square plus 5, that is to be considered as the first function. Second function is sine. Now differentiate the given function with respect to x on both the sides. So what we will get, differentiation of y is dy by dx. First function is x square plus 5. Differentiation of x square plus 5 is 2x into differentiation of sine is cos. So cos of x square plus 5. Finish. We found the answer. Clear? Cos of x square plus 5. First function is x square plus 5. Differentiation of x square plus 5 is 2x. And the second function is sine. Differentiation of sine theta is cos theta. In place of theta we have x square plus 5. Accordingly, we found the answer as dy by dx is equal to 2x into cos of x square plus 5. Next, second question is question number 2. Let us see what is given. Cos of sin x, y is equal to cos of sin x is given. Now let us find the solution of this. Same procedure. Inner function is first one, outer function is second function. When I differentiate the given function with respect to x on both the side, we get dy by dx is equal to differentiation of first function. What is the first function? Sin x. What is differentiation of sin x? Differentiation of sin x is cos x. Differentiation of sin x is cos x into differentiation of cos x. Second function is cos x. We are assuming sin x as a x. Accordingly, it looks like cos x. Differentiation of cos x is minus sin x. Minus sin x. Here x is sin x itself. Suppose here if you are writing minus sign in between, instead of this minus sign, here you can write that minus sign in advance. So better you write like this, dy by dx is equal to minus cos x into sine of sin x. Finish. This is our answer. Okay. Let us move on to the next question. The next question is, we have the next question as question number 3. What is question number 3? Let us see. Question number 3 is third question. When we have a question like sine of ax plus b, y is equal to sine of ax plus b. Very simple. Again, a trigonometric function sine is having polynomial function in its body. Ax plus b is to be considered as the first function. Second function is sin x. When we differentiate this with respect to x on both the side, we get dy by dx is equal to ax. Differentiation of ax is a and differentiation of any constant b is 0. Second function is sine. Differentiation of sine is cos. Accordingly, we get cos of ax plus b. Very simple. Hardly you will not even take 1 minute. Within 15 seconds, I hope you can solve the given question. So the next one, question number 4. Question number 4 is, find the derivative of the function y is equal to secant of tan root x. Secant of tan root x. So here you can observe we have 3 functions put together. Root x is first function, tan is the second function, secant is the third function. Let them give any number of functions. We follow the same procedure. That is, differentiation of given function y with respect to x is denoted by dy by dx. Differentiation of root x is 1 by 2 root x into differentiation of tan x is secant square x. Here x is root x. First function, second function both is done. And we are left with last function, that is secant x. Differentiation of secant x is secant x into tan x. Secant of x is here tan root x into tan x. Secant x into tan x. Yes, finish. See how simple? Just in one single step we are getting the answer for the given problem. Okay. So this is our required answer. This is our required answer to the given question. That is, first function is root x. Differentiation of root x is 1 by 2 root x into differentiation of tan x is secant square x. Differentiation of secant x is secant x into tan x. Yes. Now let us enter to fifth question. Fifth question is given as y is equal to sine of ax plus b whole divided by cos of cx plus d. When we have a function which is of this form, we find the derivative of the following function by using quotient rule, that is d by dx of u by v is equal to v into u dash minus u into v dash whole divided by v square. So this is the one formula which we use to find the derivative of function which is of the form u by v, quotient rule we call. So now differentiate LHS with respect to x, so that we get differentiation of y with respect to x is denoted by dy by dx is equal to, write the formula and then you write, because when we are finding the derivative of a function using quotient rule, we should write formula and then you write the answer according to this formula only, so that we can avoid our mistakes. V into u dash, v is nothing but the denominator, that is cos of cx plus d into differentiation of sin x is cos of ax plus b into a. V into u dash is done, minus u into v dash, where u is nothing but here sine of ax plus b into differentiation of cos x. Differentiation of cos x is minus sin x. Already we have one minus sign. Minus into minus will become plus. So differentiation of cos x is sine of cx plus d into c whole divided by denominator. Whole divided by denominator, we get denominator the whole square, that is v square. V square is nothing but cos of cx plus d, the whole square is nothing but cos square of cx plus d. Now we can split the answer which is of the following form, that is dy by dx is equal to dy by dx is equal to first term divided by denominator. What is first term here? Cos of cx plus d into cos of ax plus b into a whole divided by denominator, where the denominator is cos square of cx plus d, plus second term. What is second term? Second term is sine of ax plus b into sine of cx plus d into c whole divided by same denominator, that is cos square of cx plus d. Now if I simplify this, let us see what will happen. See here, cos of cx plus d, cos of cx plus d are one another the same. You should consider the same function. See, cos of ax plus b is not same as cos of cx plus d, because here angle is different. But these two are same, that is cos of cx plus d and cos of cx plus d are same. So numerator of one term and the denominator of one term is cancelled. Then the remaining is, I am writing the remaining terms, that is dy by dx is equal to dy by dx is equal to 1 by cos is nothing but secant. So a into, because a is here, so that a I am writing in the beginning. So a into and the remaining thing, that is a into cos of ax plus b, cos of ax plus b divided by, in the denominator we had cos of cx plus d. 1 by cos will become secant, so that we can write secant of cx plus d, plus in the second term, can we cancel any of the term? Okay, here sine by cos, since we are considering with the same angle cx plus d, so second term will become sine of ax plus b, we are writing as it is. I am combining one sine with cos, so that we get tan of cx plus d, and one more cos will remain. That cos I will write in the numerator, so that becomes secant of cx plus d. Yeah, I hope it is visible. This must be our answer. Okay, fifth question. Next one is cos of x square into sine square of x power 5. Sixth question, cos of y is equal to cos of x square, x cube, cos of x cube into sine square of x power 5, sine square of x power 5. See, as the questions are increasing, level of difficulty also they are gradually increasing. Not too difficult, it is easy only, but gradually they are increasing. Now see, in the previous problem, fifth question we did as by using u by v rule, but now we have to use here uv rule. I am writing one formula, d by dx of uv is equal to u into v dash plus v into u dash. This is the formula. Okay. So this cos x cube is to be considered as a u, and the sine square of x power 5 is to be considered as a v. Clear? If you want, you can rewrite the function like this. Cos of x cube into sine of x power 5 whole power 2 we can write. Because we all know very well that sine power n theta can also be rewritten as sine theta to the power whole n. Like this we can write. Okay. Now find the derivative of the given function. I am writing directly. Differentiation of y with respect to x is dy by dx is equal to u into, where u is nothing but cos of x cube. Differentiation of v we should write. So first of all, you should consider the inner function is x to the power 5, first function. Second function is sine. The third function is x power n format. Okay. Accordingly, differentiation of x power 5 is 5x to the power 4 into second function is sine. Differentiation of sine theta is cos theta. So cos of x power 5. And the third function is x power n format. So that is x power 2. Differentiation of x square is 2x. That is 2 into sine of x power 5. Finish. U into v dash is done. Plus v into u dash. What is v here? V is sine square of x power 5 into differentiation of cos of x cube. In the cos of x cube also we have two functions. One is x cube and the second one is cos. So differentiate one after the other. The first function, differentiation of x cube is 3x square into differentiation of cos x is nothing but minus sin x. So minus sine of x cube. So better we will write in the bracket. Now if I rearrange the answer will become which is of the following form, that is dy by dx is equal to, see here you can write the answer in two different ways. By combining 2 sine x power 5 cos x power 5 is looks like 2 sine theta into cos theta format. So you can write it as a sine 2 theta, that is sine of 2 into x to the power 5. Or you can multiply this 2 with 5 x power 4. Accordingly, we get 5 2s are 10 x power 4 into remaining functions. Like that also you can write. So 5 into 2 is 10 into, I will write both the ways, 10 x power 4 into 10 x power 4 into cos of x cube into cos of x power 5 into sine of x power 5. This is first term. Okay, na? Sine of x power 5. Yeah. Followed by that the second term. In the second term here plus into minus is minus. Plus into minus is minus. Remaining is 3x square into sine x cube into sine square of x power 5. This is one answer we can write, or even you can write the alternate answer, which is of the following form as I said in the beginning. So here we can write dy by dx is equal to, when I combine 2 sine theta cos theta, that can be written as sine 2 theta. So the remaining terms will remain same, that is 5x power 4 into cos x cube into sine 2 theta, that is sine of 2 into x power 5. Finish. This is the first term. Minus second term is 3x square into sine of x cube into sine of x cube into the last term is sine square of x power 5. Sine square of x power 5. Finish. This is our required answer. Hope you have understood. I am highlighting the answer. Either you can consider this as a final answer, or you can consider this one as our final answer. Okay. Yes. Dy by dx is equal to either this or this. Hope you have understood. Now let us move on to the next question. The next question is question number 7. So 7th question is 2 into root of cot x square. 2 into root of y is equal to 2 into root of cot x square. So now let us find the derivative of the given function. Here also you can rewrite the given question, which is of the following form, that is let y is equal to 2 into cot x square whole to the power 1 by 2, so that we can easily identify what is first function, second function, third function, or else even you can consider it in the form of root of something. You can consider first function, second function, third function, or from inner onwards, from inner functions you can consider. So I am differentiating according to this. Differentiation of y is denoted by dy by dx is equal to 2 is a constant we are writing as it is. First function is root x format. Differentiation of root x is 1 by 2 root x. Accordingly we get 1 by 2 into root of cot of x square. 2 and 2 can be cancelled. So first function is done. Second function is cot x. What is differentiation of cot x? Differentiation of cot x is equal to minus of cosecant square x. Accordingly we found minus cosecant square of x square. Second function is also done. And the third function is x square. What is differentiation of x square? That is 2x. Finish. But here we cannot write the final answer, which is of this form, because we need to further simplification. And moreover, in your NCERT textbook they have given simplified answer. So what we can do is we are writing minus 2x as it is in the numerator, and now 1 divided cosecant square x I am writing as its reciprocal. 1 divided cosecant square x square can be written as 1 divided by sine square x square. The remaining root of cot of x square will remain same. Now this sine square x can be rewritten as sin x into sin x in the denominator. So minus 2x is as it is, sine of x square into sine of x square into root of cot of x square. This cot of x square can be written as cos of x square divided by sine of x square we can write. Okay, the root is applicable for both numerator as well as denominator. So 1 sin x square can be rewritten as root of sin x square into root of sin x square we can write. From this 1 term can be cancelled. Okay, numerator of sin x square, denominator of sin x square is cancelled. We are left with minus 2x whole divided by root of sin x square into root of cos x square, and this one looks like root a into root b together can be written as square root of ab. So I can write it in the form of root of ab. I'm combining sin x square cos x square, so that we get sin of x square into cos of x square will get. Now along with this, if I have multiply and divide by 2, then the numerator of these three terms, that is 2 sin x square cos x square, will look like 2 sin theta cos theta format. Accordingly we get minus 2x into 1 by sine is nothing but cosecant, so cosecant of x square, and within the root we get root of 1 by 2 into sine 2x we can write, that is sine 2 into x square. And if I apply square root separately, finally we obtain the answer as dy by dx is equal to minus of 2x into cosecant of x square. Now denominator of denominator will go to numerator, that is 2 root 2 we can write, 2 root 2. So better I will write as neat as possible, that is minus 2 into 2 root 2x into cosecant of x square whole divided by root of sine 2x square. Finish. This is our required answer. Hope you have understood. Moving to the next question, that is question number 8. So 8th question is very simple, that is y is equal to cos of root x is given, cos of root x. Only two functions. First function is root x, second function is cos x. So differentiate this. What we will get? So differentiation of this one will become dy by dx is equal to differentiation of root x is 1 by 2 root x, and differentiation of cos x is equal to minus of sin x. Accordingly we will get minus sine of root x. Finish. This is our answer. Minus sine root x whole divided by 2 root x. Clear? I hope it is clear. Moving to the next question, that is question number 9. What is 9th question? Let us see. 9th question is prove that the function f given by I will move in the next slide. I will write it in the next slide. Prove that the function f given by, prove that the function f given by f of x is equal to modulus of x minus 1, f of x is equal to modulus of x minus 1 for all x belongs to real number, for all x belongs to real number, is not differentiable at x is equal to 1, is not differentiable at x is equal to 1. Okay. Now to find the solution of the given problem, here we use the method of derivative of first principle method we use. And moreover, as I have observed from my 14 years of experience, these last two questions they have not given not even once in your annual examination. So even if you exclude these two questions also, nothing to worry. But still in the exercise it is given, so I am discussing the problem. So we use the method of first principle. The derivative formula says that f dash of x is equal to limit h tends to 0 of f of c plus h minus f of c whole divided by h. And here we say that the given function is differentiable only if left hand derivative is equal to right hand derivative. If left hand derivative is not equal to right hand derivative, we can say that the given function is not differentiable at a given point. So let us find the left hand derivative and right hand derivative respectively. I am finding first left hand derivative. So I will consider left hand derivative is limit h tends to 0 minus of f of c plus h minus f of c whole divided by h. Here c is nothing but value of x, that is 1. So when I find left hand derivative, we get limit h tends to 0 minus of f of 1 plus h minus f of 1 whole divided by h. So this is equal to limit h tends to 0 minus of f of 1 plus h. Our function f of x is modulus of x minus 1. F of 1 plus h is replace the value of x by 1 plus h. That is only f of 1 plus h. So we get 1 plus h in the function f of x. I am writing in place of x I wrote 1 plus h. This minus 1 is as it is, minus f of 1. F of 1 is nothing but you will replace the value of x by 1 in the given function. So this is our function f of x. Wherever x is there, replace the value of x by 1, we get f of 1. That is f of 1 is equal to modulus of 1 minus 1. That is what I had written here. Now if I simplify this, we get limit h tends to 0 minus of plus 1 minus 1 cancelled. So 1 minus 1 is 0, remaining is modulus of h, minus 1 minus 1 is 0, that can be neglected. So here we get limit h tends to 0 minus of limit h tends to 0 minus, when the value of h is lesser than 0, mod h will be minus h. So minus h whole divided by minus 1. We will get minus 1 as h tends to 0. So this is our value of left hand derivative. Okay, left hand derivative value is minus 1. Now let us find the right hand derivative. Let us cross check whether we get the same or not. Now to find the right hand derivative, I am considering limit h tends to 0 plus of limit h tends to 0 plus of limit h tends to 0 plus of f of c plus h minus f of c whole divided by h. Again I wrote the formula. So here we write limit h tends to 0 plus of f of 1 plus h minus f of 1 whole divided by h. So we already know that the value of f of 1 plus h and f of c. F of 1 plus h value is, in the given function f of x, we are replacing the value of x by 1 plus h. Minus 1 is as it is, minus f of 1 is modulus of 1 minus 1 whole divided by h. So when I simplify, minus 1 plus 1 cancelled, here also minus 1 plus 1 cancelled, remaining is limit h tends to 0 of plus h we will get, that is mod h whole divided by h is left. Modulus of h when the value of h is greater than 0 is plus h by h is equal to 1. So we found the right hand derivative as a plus 1. So now you can compare left hand derivative and right hand derivative. Since left hand derivative is not equal to right hand derivative, therefore the function f of x is not differentiable at x is equal to 1. At x is equal to 1. Hence proved. Hope you have understood. We are left with the last question, that is, prove that. Let us move to the last question in this exercise. So entire chapter exercise will get over. So the given question is 10th one. Prove that the greatest integer function defined by f of x is equal to greatest integer value of x, where the value of x is in between 0 to 3 is not differentiable at x is equal to 1 and at x is equal to 2. Okay, this is the last question in this exercise. Let us try to find the solution of the given problem. As we did the 9th question, like that only we should find the solution of the given problem, that is by using the first principle method. So I am writing formula once again. The derivative of first principle says that f dash of x is equal to limit h tends to 0 of f of c plus h minus f of c whole divided by h. This is the formula. Now let us divide the given problem into two cases. Case number 1 for case 1 at x is equal to 1. Now I am finding left hand derivative and right hand derivative, and let us compare both, then we will decide whether they are equal or not. And we have to prove that it is not differentiable, which means we should prove that left hand derivative is not equal to right hand derivative. So I am considering left hand derivative, that is limit h tends to 0 minus of f of 1 plus h minus f of 1 whole divided by h, because we are finding at x is equal to 1. Accordingly, we get limit h tends to 0 minus of f of 1 plus h is nothing but greatest integer value of 1 plus h minus greatest integer value of 1 whole divided by h. Now see, when the value of h is lesser than 0, you can assume that the value of x must be lesser than 0. Assume the value of x is lesser than 0. Lesser than 0 means you can take the value of x is minus 0.5. If I take the value of x is minus 0.5, we get 1 minus 0.5 is nothing but 0.5 we will get. The greatest integer value of minus 0.5 is, okay, first fine, we are replacing the value of x by minus 0.5. So 1 minus 0.5. If I take the value of h is equal to minus 0.5, we get greatest integer value of 1 minus 0.5 is, okay, I will better substitute here so that you will understand. 1 minus 0.5 minus greatest integer value of 1 is as it is whole divided by h, which is equal to limit h tends to 0 minus of greatest integer value of 1 minus 0.5 is nothing but 0.5, clear, minus greatest integer value of 1 is 1 whole divided by h. So here we get the greatest integer value of 0.5 is minus greatest integer value of 0.5 is 0 minus 1 whole divided by h. Limit h tends to 0 minus of minus 1 divided by h. As h is tending to 0, we get infinity as an answer. So left hand derivative, we found it as infinity. Now when I move to right hand derivative, let us see what we will get. Right hand derivative is equal to, same procedure we follow, and let us see what answer we will obtain for this. That is f dash of x is equal to limit h tends to 0 of, writing formula once, f of c plus h minus f of c whole divided by h. Now at x is equal to 1 we are finding, so f of 1 plus h minus f of 1 whole divided by h. What is f of 1 plus h? The value of f of 1 plus h is nothing but replacing the value of x by 1 plus h in the given function. What is our given function? F of x is equal to greatest integer value of x. So we get greatest integer value of 1 plus h minus greatest integer value of 1 whole divided by h. That is limit h tends to 0 of 0 plus. If I take the value of h as a greater than 0, assume 0 0.1, 0 0.2, 0 0.3, like that. You can take any value which is greater than 0. So 1 plus 0 0.5. If I assume the value of h is equal to 0 0.5, we get 1 plus 0 0.5. What is 1 plus 0 0.5? That is 1.5. Greatest integer value of 1.5 will become 1. Minus greatest integer value of 1 is 1 only we will get. Whole divided by h. What is 1 minus 1? 0. Left hand derivative we found it as a infinity, and right hand derivative we found it as a 0. So we conclude here, since left hand derivative is not equal to right hand derivative, therefore the function f of x is not differentiable at x is equal to 1. I hope you have understood. Now let us enter to the second part of the given problem at x is equal to 2. Okay, that is at x is equal to 2, and the function was given very clearly, f of x must be greatest integer value of x. So now if I find the solution for this at x is equal to 2, here also we follow the same procedure. First let us find left hand derivative and right hand derivative, compare both. If both are same, we can say that the given function is differentiable. But since in the question itself they are asking you to prove that the given function is not differentiable at x is equal to 2, so we should prove that left hand derivative is not equal to right hand derivative. So finding left hand derivative. First I will write the formula, limit h tends to 0 minus of f of c plus h minus f of c whole divided by h. See dear students, I explain here what is the difference between f of x and f of c plus h. F of x is already given here. Okay, what is that? Greatest integer value of x. If f of x is equal to greatest integer value of x means what will be f of c plus h? Just replace the value of x by c plus h. That's it. Clear? Greatest integer value of c plus h. This is what I was using in the previous slide. Now if I use the same in the given question, and if you want to know the difference between f of x and f of 1, f of 1 is nothing but greatest integer value of 1 is nothing but 1 only will get. So I am substituting this in the left hand derivative. Left hand derivative is equal to limit h tends to 0 minus of greatest integer value of 1 plus h is, okay, at x is equal to 2 we are finding, better you consider this as a 2. Greatest integer value of 2 is 2 only. So we get f of 2 plus h minus f of 2 whole divided by h. So we get limit h tends to 0 minus of f of 2 plus h is nothing but greatest integer value of 2 plus h minus greatest integer value of 2 whole divided by h. So what is greatest integer value of 2 plus h when the value of h is lesser than 0? If I take the value of h as a lesser than 0, we get 2 plus minus 0.5. Let h is equal to minus 0.5 because we are looking for lesser than 0. So if I take the value of h as a lesser than 0.5 and lesser than 0, I am taking as a minus 0.5. So 2 minus 0.5 is 1.5 we will get, and the greatest integer value of 1.5 will be 1 only we will get. Okay, minus greatest integer value of 2 is 2 whole divided by h. So we get limit h tends to 0 minus of 1 minus 2 is minus 1 whole divided by h. As h is tending to 0, we get infinity as an answer because 1 by 0 is infinity. So we found the left hand derivative, that is infinity we are getting. Now let us find the right hand derivative. If I find right hand derivative, what we'll get? Let us see. Right hand derivative is equal to limit h tends to 0 plus of f of c plus h is nothing but 2 plus h minus f of c, that is 2 whole divided by h. We get limit h tends to 0 plus of f of 2 plus h is greatest integer value of 2 plus h minus f of 2 is nothing but the greatest integer value of 2 whole divided by h is as it is. Since we are looking for the value of h is greater than 0, assume the value of h as a 0.5 greater than 0. It may be 0.1, 0.2, 0.3. In between 0 to 1 you can take any value. If I take any value in such a way, as of now I am taking 0.5. 2 plus 0.5 is nothing but 2.5, and the greatest integer value of 2.5 is nothing but 2 only will get, and the greatest integer value of 2 will remain same, whole divided by h. Greatest integer value of 2 is 2. Clear? Greatest integer value of 2 is 2. So 2 minus 2 divided by h. What is 2 minus 2? 0. 0 by anything is 0. So right hand derivative we found it as 0. So now you can write the conclusion. Since left hand derivative is not equal to right hand derivative, therefore f of x is not differentiable. F of x is not differentiable at x is equal to 2. Hence proved. So this is all about the entire exercise. 5.2 exercise, derivative of composite functions. I hope I have explained as simple as possible. So in the next video, we'll move to the derivative of next exercise, 5.3. Thank you.